So first let's start with a warm-up. Let A and B be sets in the universal set U. Write in set notation, the notation I taught you before with the brackets, da-da-da, line, da-da-da, brackets. So write in set notation the following sets: A union B, A intersect B, and A complement. Okay, so you can pause the video and try that out, but I'm about to give the answers. So A union B, kind of the idea, so remember we were talking about the bowls. Oh, I was going to get bowls for this video. Forgot about that. Oh well. So we have two bowls, let's say, and we're just dumping them together, right? So we have elements X, let's say, and so remember the line's not our only option, we can also write colon. So X such that X is in A or X is in B, right? Because if you're in the bowl that you got dumped into, you were either in A or B, but you could have been in both. Okay, so it really should read X in A and or X in B, but or sometimes we leave that open to, well, it could just be both, right? So I'm having fries or onion rings with lunch today. Well, maybe I'm having both. So let's say Y is in A union B. Okay, just some random element in there. So you could say then Y is in A and or Y is in B. Okay, so that's not a true dichotomy. So that might be a weird word, and that's okay. So di is talking about referring to two. So what it means is if one is true, then the other has to be false. Or if the other one's true, the other one has to be false. Okay, so that's like flipping a coin. You flip a coin that has heads or tails on it, you can't say, oh, I flipped it and it's tails and heads. Flipping a coin is a true dichotomy. You're either heads or you're tails. You can't be both, right? So here, this is not a dichotomy. Okay, so, but a lot of people forget that. They think, oh, you're either in A or you're in B. But it is possible that you're in both. Okay, so another example of a true dichotomy is Y is in A or Y is not in A. So that's true. That's a true dichotomy. Okay, that you can't say and or with that. That is a strict or, either or. Okay, because you can't be in Y but then also not in Y. See what I'm saying? Okay, I hope that made sense. All right, let's move on to the next one. So and X such that X is in A and X is in B. So A complement, remember we talked about before, we could also write this as U minus A. So how would we write that? We would say X such that X is in U and X is not in A. Okay? So if we think about it, to show an element is in the union of A and B, so A union B, all we need to show is that the element is in one of them, right? So if we show that it's in A, then we know it's in the union. We don't even care. It might be in B, it might not be. We don't care. To show that an element is in A intersect B, we need to show that that element is in A and it's in B, okay? So to show that an element's not in A intersect B, all we have to do is show it's not in one of them. How cool is that? And then it's the opposite for the union, right? So if you're trying to show an element's not in the union, you have to show that it's not in A and it's not in B. Because if it's not in A, that's okay, maybe it's in B. Okay, so you need to show, okay, it's not in B either. All right? So a lot of the time when you're trying to do these problems, a lot of time just talking them out and like thinking about what situation you're in, what you want to be true is going to be very helpful and very enlightening. So A complement, all that means is we want our element to be in the universal set, but it's not in A. So it's just like outside of A. Okay. So to show that something's in A complement, what we want to do is we want to show, well, first it just needs to be an element in our universal set. And then we want to show that it's not in A. Let's move on to our section. First, I want to recall if A and B are equal, then A is a subset of B and B is a subset of A. Okay? So if we remember, if A is a subset of B, that means any element in A, we can also find it in B. Okay? But we also have, if you remember back to my video, I said also if A is a subset of B and B is a subset of A, then A equals B. So to prove that A equals B, we need to show two things. We need to show that A is a subset of B and that B is a subset of A. Okay, so let's show an example. But a few notes that I want to mention before we start the example is I want to say there's a lot of different correct ways to do this. Okay. So the analogy that I tend to use is the skeleton should be the same, at least for this class. Okay, once you move on, there's going to be lots and lots of different ways to prove some crazy stuff. Okay, later on in life, you might do some crazy complex stuff that's just the skeletons could look totally different. Maybe they're not even related. So the skeleton for this class, most of the skeletons are going to look the same, but the meat could be different. And so what I mean by that is I'm going to show you a process, and your process still needs to be the same of, okay, I show A is a subset of B. Then I show B is a subset of A, if I'm trying to show A equals B. Then I write my conclusion. Okay, so that skeleton still needs to be the same. You could reverse these two, but you still need to have them in there, right? But your details could look totally different, or you could talk about things differently than I do. And that is totally okay. Part of this class is going to be exploring how you want to, what your style is going to be. And that's going to be another great part of group work, is you'll get to see other people's ways of thinking about things. So another thing I wanted to mention is show and prove I use interchangeably. And also other words, I think. I can't think right now. Except for convince yourself. When I talked about convincing yourself with Venn diagrams, that's just a rough sketch. You're not talking about every single detail. You're just kind of thinking about it. You're spending time thinking about it until you feel like you understand why it's true. Okay? So why I kind of use prove and show interchangeably, well, that's kind of how I live my mathematical life. But why I do it with teaching is because you might go up into higher level classes and maybe the professor sees prove and show differently. Like maybe one is stronger than the other or something. But you'll go in just doing all of it the strongest. Okay, so you won't lose any points. Maybe the professor will pull you aside and they will say, hey, like, when I talk about show, I don't mean you have to do every detail. It's more of like this or that. But that's going to be a professor by professor basis. Okay, so for me, I just want to prepare you for everything. Okay, so in this class, when we say show, we also mean prove. When we say prove, we also mean show. They're just kind of interchangeable. Okay, all right. The last thing that I want to say is the first time I go through this proof, just watch. Okay, I'll go over it again and then you can take notes that time, but I really ask that you just watch this time. Okay, all right, let's get started. So I always start, because I'm a big proponent for clear communication with the reader. Okay, you don't want to give anyone any reason to not give you the points. Okay, so I always start by writing proof. I want to make it clear, this is where I'm starting, and then I put the little box at the end to say this is where I'm ending. Okay, I want it clear and concise. I want to make the grader have the easiest time ever. Okay, so proof. And I also shorten it to PF. So I am going to start with this. And so what I mean is I'm trying to show this containment. So I'm trying to show that this is a subset of this. Okay? So I'll talk about that more later. Not necessary. It's just that's how I like my notation. I don't have very good memory, so it's always good to keep things clear with myself and the reader. It also helps the reader. They know what I'm trying to do. All right, so I want to start with just some element in the left-hand side. So A union the set B intersect C. Okay? Because remember, I just want to show that any element over here is also over here. Okay? So let X, some element X, be in A union the set B intersects C. Okay? So notice I'm not saying anything specific about X. X is just an element. I'm not saying X is an element that is in A. I'm just saying X is in there somewhere. Then, so since X is in here, X is in A or X is in B intersect C. So now maybe you understand why I did that warm-up with us, right? So this is literally just by the definition of the union, okay? So one of those two things are true. Maybe both are true. We don't know. I'm already kind of stuck, aren't I? Well, here's what I'm going to do. I'm going to talk about what it is that I want. So I want to show that this generic element over here is also over here. Okay. So I want to show that any element over here is over here, right? That's the goal. So I want to show that this random element X is in this set. Okay, so X in A union B intersected with A union C. Okay, so I want to show that, but what does that mean? What does it mean for X to be in here? Once again, our warm-up was very helpful. It means that X needs to be in here and in here. Okay, so I say X is in A union B, and X is in A union C. Okay, well, what is it? Let's break it down further. So maybe let's split it. So if X is in A union B, then that means that X is in A, or X is in B. Similarly over here, X is in A or X is in C. Okay, now I feel a lot better. So in order to get what I want, which is showing that X is in here, to get what I want, I need to show that X is in A or X is in B, and X is in A or X is in C. See how I did that? So this and still follows through, okay? Because it's not enough to show that X is in B, because I also need to show that X is in A union C. And B and A, C, maybe they don't have anything to do with each other, okay? But the one caveat is if I show that X is in A, boom, I got both sides, okay? But we could talk about that in a second. So I always like to put it in brackets, or you could put like a dream cloud around it or something. I just like to make it clear to the reader that I am not assuming this, okay? Because to prove something, I would have to actually give proof. I can't just say, well, assume it's true. Boom, I'm done. I proved it. All right, so now I have what I want. Now I have a clearer vision of where I'm going. So I already have, this is where I left off with the information that I have. Okay, I have that X is in A or X is in B intersect C. Okay, so if X is in A, then we're done. Just with this part of the proof, not with the whole thing. Then we're done because A is a subset of A union B, and A is a subset of A union C, so X is an element in A union B, and X is an element of A union C. Because X was an element of A, right? And so we're just, all I'm doing is we're using definition of union. Okay, that's all that I'm using for this. That's pretty much our only tool that we got right now, are definitions. Okay, great. So that's one option. So our next one is if X is in B intersects C. Remember that was our other option. Okay. So it could be both. It could be that both are true, but that's fine, right? So if X is in A, we're done. We don't even care if it's in B intersects C. So now this one, what I'm kind of saying is if X is not in A, but it's in B intersects C, then we have more stuff, right? I'm going to still show that it's true. But I don't even need to assume that X is not in A. Okay, and you'll see in a second. So I'm not claiming a dichotomy here because this is not a true dichotomy. So if X is in B intersects C, what does that mean? Wow, warm up again. Then X is in B and X is in C. Wait a second. Whoops. That's exactly what I wanted. I wanted X to be in A or X to be in B, and X to be in A or X to be in C. So I could choose out of those options X to be in A, X to be in B, and X to be in C. Perfect. Okay. So now in my head, I can just do this stuff backwards now. Okay? I can say since X is in B, so since X is in B, since this is true, then I know that this is true. And since that this is true, then I know that this is true. Okay, now I have that both of these things are true. So then I have that this is true. Okay? Since B is a subset of A union B, and C is a subset of A union C, then X is an element of A union B, and X is an element of A union C. Okay? And so I know I kind of didn't make this as clean as I maybe wanted to, but so from this and this, so I add those two parts together, I get this. Okay? And then similarly from this and this, those two together, I get this. And now, from these two together, I'm going to get the result that I wanted. Oh, I forgot to write the result above. My apologies. This is why another piece of advice I'll give you is I learned this pretty early on, which is good. Which probably was by accident. It was probably just because I have bad memory. But you're going to want to constantly be rereading what you wrote before and like making sure that everything makes sense and that you're going the right direction and things. And that's why I also talk about stuff that I want. All right, so now I want to say here, therefore, X is in A union B intersected with A union C. Okay? Because X was in here, and X was in here, and X is in here. Okay? Okay, so that was just one if statement. Now here's our other if statement. And so I'm just going to write the same thing. Therefore, X is in A union B intersected with A union C. Okay, now we've covered all of our bases. Okay, we've talked about, so we know that X is in A or X is in B intersects C. We know it's one and or the other. Okay, and then we went back and we talked about, well, so what if it's the first option? Okay, Talk about what if it's the first option. Okay, if it's the first option, we still get what we want. If it's the second option, we still get what we want. So if it's both of them, yeah, we're still good. So now I've shown this. Okay, I chose some random element in A union B intersect C. And I showed that that element is also over here. So that means I've shown containment one way, or subset in one direction. Therefore, A union B intersect C is a subset of A union B intersected with A union C. Okay, are we done? I hope you shouted at your screen no, just like it was Dora or something. So no, we're not done, because remember we have to show the other way. Alright, so I showed this way, now I'm going to show this way. Okay, so I want to show that A union B intersected with A union C is a subset of A union B intersect C. So the first thing that I do is I just grab some random element, let X be in the thing that I want to show is a subset of the other. Okay, so I grab it from over here. Okay, so X is just some random element over there, and now I want to show that it's in A union, the set B intersects C. So what does it mean to be in this set? Well, it means to be then X is in A union B, and X is in A union C. So sometimes strategy with proofs is just keep saying true things that you're just hoping are moving you forward. Okay? Because sometimes you're going to look at a proof and you're not going to really understand it right away. Okay, so then X is in there and X is in there. Okay. So then I guess let's think about what does that mean. Then, so sometimes when I want to like split up statements, I'll put parentheses around them. X is in A or X is in B, and X is in A or X is in C. All right, I'm already kind of feeling stuck. So let's talk about what I want. All right, so what do I want? I want X to be in A union B intersect C. Okay, well, what does that mean? Then X is in A or X is in, B intersect C. Okay, so once again, I'm just going to rewrite this. And then what does it mean for X to be in the intersection? Well, it has to be in both. X is in B, and, so remember this just means and. It's an ampersand. X is in C. Okay, so X is in A, or this whole statement, that X is in B and X is in C. Okay, so how about let's start out with, if X is in A, then boom, we already have what we want. Okay, so let's start with that. So if X is in A, then since A is a subset of A union B intersect C, then X is an element in A union B intersect C. Cool. Okay, so if X is in A, then we're all set. That's nice. So we could now go to if, so we could talk about what if X is in B. But just because X is in B up here, that doesn't mean that X is also in C. It could be that X is in B and X is in A, so that's why it's in the intersection. Okay, so here's how I'm going to start approaching this. I'm going to use the true dichotomy that X is either in A or it's not in A. Okay, so let's do that. So if X is not in A, then what has to be true? Let's look at our statement again. So if X is not in A, so if that's not an option, that's not an option, oh man, then X has to be in B and X has to be in C. Okay, so that gives us exactly what we want. Then X is in B and X is in C. Since X is in A union B intersected with A. So you just always want the grader to know that you know what you're talking about. So I know that that's true because of this. Now what's next? So because of this up here, then by the definition of intersection, X is in B intersects C. Wait a second, that's what we wanted. So since B intersects C is a subset of A union B intersects C, and that's just by definition of union, then X is an element of A union. Therefore, A union B intersected with A union C is a subset of A union B intersects C. Okay, cool. All right, so now I have containment both ways, so now I can write my conclusion. Therefore, since, and so oftentimes I'll just write shorthand like this, that, and that, then A union B intersected with A union C is equal to A union B intersects C. And now that's the end of my proof. I wrote my conclusion. I'm all done. I showed what I wanted to show. So I put my little box and I filled it in. Okay, so we proved what we wanted to show. So now we're done. So now let me zoom out a bit. Hopefully you can still see it. And let's just go through it again. Or you can watch the video again, I guess. So this is what I wanted to show. I know I have two steps. Okay, I have to show containment this way, then I have to show containment that way. So in order to show that A union B intersects C is a subset of the other set, I have to take some random element from there. Random element from who I want to show is a subset. And then I'm just talking about what's true. Okay? And then I'm like, all right, well, I don't really know where to go from here. Let's talk about what I want. Okay, but I'm not assuming what I want. I'm just talking about what I want in my little dream space. Okay? So I'm talking about what I want, and then I go on, and now that I know where I'm going, now I start with, okay, well, let's say X is an A. Okay, I know that's one of the options. X could be an A. So if X is an A, then all this stuff is true. I'm basically doing what I said I wanted, but backwards almost. Okay, I'm thinking about it backwards. So, and then I get to show what it is that I'm trying to show. Perfect. Boom. So one down, but that's not enough to say that the whole thing is a subset. Because I'm only talking about this one situation when X is in A. So how about if X is in B intersects C? Or I could talk about if X is not in A, then it would have to be in B intersects C. See what I'm saying? So then I just talk about true things, and now that I've shown that for any possibility, any option that you throw at me, you say, okay, well, what about this element? Well, what about that element? What about that element? It's going to fall in one of these two categories. Some of these elements that you pick out may fall into both categories. That doesn't matter. It's true for both. So we're good. We're down. Whatever element you choose from this set, it's always going to be in the other set. Therefore, by the definition of subset, that gives us what we want. That gives us this statement. Okay, so sometimes I'll write like a little check mark because I love making lists and like checking them off. And then as you saw, we did basically the same thing in the other direction. Feel free to rewatch this video if you want more details again, or email me. Okay. Now, since we've shown subset both directions from our recall before, we know that means that the two sets are equal. So that's the end of our proof. Now let's do something where they're not equal. Two sets are not equal. So let's recall that if A and B are sets, then if A is a strict subset of B, then A is a subset of B such that you can find someone in B that is not in A. You can find an element in B that is not in A. Okay? So the example I want to show is the natural numbers are a strict subset of the integers. Okay? So by looking at their two sets, this may just be like, Danica, why are you wasting your time with this? But like I said, I just want to build up some good habits now when it's very, very understandable. Okay, when you could just look at it and understand it and then apply the concepts so that later when you're looking at something and maybe you're not understanding it, you can still apply those concepts and you can still see what's happening. Okay. All right, so let's start the proof. So still, I need to show two things, okay, with this. So if I'm trying to show something as a strict subset of something else, I need to show that it's first a subset, and second, that there is an element in B that is not in A. Okay? So proof. So first, I want to show that it's the subset. Let X be in, then X is a positive whole number. Since the integers are all of the whole numbers. By definition. And I'm imagining our universal set is the reals, or the real number line. By definition, then X is an element in Z. Therefore, natural numbers are a subset of the integers. Check. Okay, now I need to show that it's strict. Okay, so pick an element in the integers. So let's say -2. -2 is in Z. So now notice I don't have to say like if or let, because I can literally pick something specific now, because I only need one to break it. Okay, you only need to find one element in Z that's not in the natural numbers to make it that the natural numbers are a strict subset of the integers. Say since -2 is negative, kind of sounds kind of silly when you say it out loud, but then -2 is not in the naturals. But remember, later on, you might be talking about two sets and they're just insane, right? It might not be kind of silly like this. So I just want to build good habits and show you some things while it's still very comprehensible. Therefore, the naturals are a strict subset of the integers. And you always want to write a conclusion, please. Always, always, always.